A history of sparkle from ancient legends to modern marvels. Diamonds. These precious stones have a story that spans millennia, weaving through the fabric of human history and culture. For centuries, these shimmering stones have captivated humankind. Their allure is not just in their beauty, but in the mystery and legends that surround them. Their mesmerizing brilliance and unparalleled hardness have made them objects of desire, symbols of power and tokens of love. From engagement rings to royal crowns, diamonds have always been a testament to wealth and status. Ancient civilizations, captivated by their ethereal beauty, believed diamonds held celestial powers, born from lightning strikes or tears of the gods. These myths added an aura of mystique to the already enchanting stones. The ancient Romans and Greeks viewed diamonds as tears of the gods and splinters from falling stars, respectively. They were not just adornments, but were believed to be imbued with divine essence. They believed these sparkling stones held divine powers, capable of warding off evil and bringing good fortune. Warriors would carry diamonds into battle, believing they would protect them from harm. India, with its legendary diamond mines, was the first to recognize the true nature of these gemstones. The Indian subcontinent was the primary source of diamonds for over 2,000 years, and its mines were the stuff of legend. They discovered that diamonds were not simply beautiful trinkets, they were the hardest known natural material, capable of cutting through even the toughest substances. This discovery revolutionized the way diamonds were used and valued. Over time, diamonds journeyed from the hands of emperors and sultans to the courts of Europe, adorning crowns, scepters, and the fingers of nobility. They became symbols of power and authority, worn by those who ruled nations. Their allure only grew, solidifying their place as the ultimate symbol of luxury and prestige. Today, diamonds continue to captivate us, representing not just wealth, but also the timeless beauty and enduring strength that have fascinated humanity for centuries. The journey of a natural diamond begins deep within the Earth's mantle, far beneath the surface where the conditions are unlike anywhere else on our planet. This is a realm of immense heat and pressure, a place where the environment is so extreme that it can transform simple carbon into one of the hardest substances known to man. It's a journey that takes billions of years and requires a unique combination of extraordinary circumstances. Over these vast stretches of time, geological processes work tirelessly, shaping and reshaping the Earth's interior. Imagine a crucible where temperatures soar to over 2,000 degrees Fahrenheit, a heat so intense that it can melt rock and metal alike. In this crucible, the pressure is 50,000 times greater than at sea level, a force so powerful that it can crush almost anything in its path. In this extreme environment, carbon atoms, the basic building blocks of life, bond together in a tetrahedral structure. This unique bonding is what sets diamonds apart from other forms of carbon, like graphite. The tetrahedral structure forms an incredibly strong and rigid lattice, making diamonds not only hard but also exceptionally durable. This unique arrangement of atoms is what gives diamonds their exceptional hardness and brilliance. It's why they can cut through almost any material, and why they sparkle with such intensity. As molten rock, known as kimberlite magma, rises from the Earth's mantle, it carries these precious diamond crystals with it. This journey from the depths to the surface is both violent and transformative. This fiery ascent creates pipe-like formations known as kimberlite pipes, which are the primary source of natural diamonds today. These pipes act as conduits, bringing diamonds closer to the Earth's surface. However, not all diamonds survive this perilous journey. The path to the surface is fraught with danger, and many diamonds are lost along the way. Many are lost to the intense heat and pressure, their structures unable to withstand the extreme conditions. Others are fractured or flawed during their ascent, their once perfect structures marred by the journey. Only the strongest and most resilient diamonds emerge from the depths of the Earth, their structures intact and their brilliance undiminished. These diamonds, having survived such an arduous journey, are finally ready to be unearthed and admired, their beauty a testament to the incredible forces that created them. While natural diamonds are born under the immense heat and pressure of the Earth's mantle, they take millions, if not billions, of years to form. These precious stones are created deep within the Earth, where temperatures can reach over 2,000 degrees Fahrenheit and pressures exceed 725,000 pounds per square inch. Over time, volcanic eruptions bring these diamonds closer to the Earth's surface, where they can be mined. In contrast, lab-grown diamonds are created in controlled laboratory environments that mimic these extreme conditions. These labs use advanced technology to replicate the natural processes, but in a fraction of the time. Instead of waiting millions of years, scientists can grow diamonds in a matter of weeks or months. There are two main methods for growing diamonds in a lab: high pressure/high temperature, also known as HPHT, and chemical vapor deposition, or CVD. Each method has its own unique process and set of equipment, but both aim to produce high-quality diamonds that are virtually indistinguishable from their natural counterparts. The HPHT method replicates the natural diamond formation process, subjecting a small diamond seed crystal to extreme temperatures and pressures within a specialized chamber. This method is particularly effective for creating larger diamonds and is often used to produce diamonds for industrial applications, as well as for jewelry. The HPHT process begins with a small diamond seed crystal, which is placed in a chamber designed to withstand extreme conditions. The chamber is then heated to temperatures exceeding 2000 degrees Fahrenheit and subjected to pressures of over 725,000 pounds per square inch. Under these conditions, carbon atoms begin to bond to the seed crystal, gradually growing a larger diamond. This process encourages the carbon atoms to bond to the seed crystal, gradually growing a larger diamond. The result is a diamond that is chemically, physically, and optically identical to a natural diamond, but created in a fraction of the time. The CVD method, on the other hand, starts with a thin slice of diamond seed crystal placed in a chamber filled with carbon-rich gas. This method is particularly suited for creating high-purity diamonds and is often used for both industrial and gem-quality diamonds. The chamber is then heated to extremely high temperatures, causing the gas to decompose and the carbon atoms to deposit onto the seed crystal, layer by layer, forming a diamond. This method allows for precise control over the diamond's growth, resulting in high-quality stones that can be tailored for specific applications. Both methods produce diamonds that are chemically, physically, and optically identical to natural diamonds. Advanced testing and certification processes ensure that lab-grown diamonds meet the same standards as natural diamonds, making them an excellent alternative for consumers and industries alike. The only difference is their origin. While natural diamonds are formed over millions of years deep within the earth, lab-grown diamonds are created in a matter of weeks or months in a laboratory setting. One is born from the earth, while the other is created by the ingenuity of science. Both types of diamonds have their own unique stories and characteristics, but ultimately they share the same brilliance and beauty that have made diamonds so highly prized throughout history. Section 4. Identical twins. The intriguing similarities. Lab-grown diamonds are not diamond simulants like cubic zirconia or moissanite. They are not imitations. They are real diamonds with the same physical, chemical, and optical properties as their naturally occurring counterparts. Both types of diamonds are made of pure crystallized carbon, arranged in a tightly bonded tetrahedral structure. This structure gives diamonds their unparalleled hardness, making them the most durable gemstone on Earth. They both possess the same refractive index, meaning they reflect light in the same way, giving them their signature brilliance and fire. In fact, lab-grown diamonds are so chemically and physically identical to natural diamonds that even experienced gemologists often cannot tell them apart with the naked eye. They require specialized equipment and meticulous examination to identify the subtle differences in their growth structures. This remarkable similarity between lab-grown and natural diamonds raises fascinating questions about our perception of value, rarity, and the allure of gemstones. Section 5. Telltale signs. Can experts spot the difference? While lab-grown and natural diamonds are virtually identical to the naked eye, experienced gemologists can distinguish between them using specialized equipment and techniques. These techniques focus on identifying subtle differences in the diamond's growth structures, inclusions, and fluorescence patterns. For example, lab-grown diamonds often exhibit different fluorescence patterns under UV light compared to natural diamonds. They may also have different types of inclusions, which are tiny imperfections within the diamond's crystal structure. These inclusions can provide clues about the diamond's origin and growth conditions. Gemological laboratories use advanced techniques like Raman spectroscopy and photoluminescence to analyze the diamond's chemical composition and identify any trace elements that might indicate its origin. These techniques help ensure that consumers know exactly what they are buying and prevent fraudulent practices.